Hello everyone. Let's look at the question where I'm asked to sketch the graph of the polar equation theta is equal to pi over 3. Normally when I graph a polar coordinate, I'm given a value for r and for theta. R being the distance from the pole to the point itself, and theta of course being how far around the pole, around the polar graph that I go, just like how far I go around a circle. So in this case, I'm only given an angle. So for my polar graph, pi over 3 puts me right here. But I'm not told how far out to go. Do I go 1 unit, 2 units, etc.? So if I'm only given pi over 3, this means it wants the value for every possible distance for r. That means it will keep on going to infinity in this direction. Now that also means r could be negative too. Now recall that with a negative value for a polar graph, since r refers to distance, we're not going to negative distance, we're looking at it as a reflection. So instead we're going this way. That means we have to consider going this way as well. So we say this is pi over 3, and this is the way the graph looks. And seeing as pi over 3 can be looked at as a reference angle, down here, that's also pi over 3, which means this graph also goes through the angle of, if I go all the way around, it's equivalent to drawing another line at 4 pi over 3. Now a second way of looking at it is, one of my conversions, one of my equations to go from polar to rectangular coordinates, or polar to rectangular form, and vice versa, is tangent of theta equals y over x. Well, I know what theta is. Theta is pi over 3. So I say, what's tangent of pi over 3? Well, I have a value for that. That's going to be the square root of 3. So if I'm putting this into rectangular form, I can solve for y by multiplying each side by x. And I'm left with the rectangular equation of y equals square root of 3 times x. Now this may look familiar to you. This is our slope-intercept form. So this implies we have no y-intercept, which if you look at this graph as a rectangular coordinate, you can see it goes through the origin. My slope is the square root of 3. Square root of 3 is 1.732. And that's reasonable for the graph that I've drawn. It's positive. It seems steeper than a slope of 1, which would go right through the center at about 45 degrees. So you can see this will verify our graph. In rectangular coordinates, it's the graph of y equals the square root of 3x. So again, if I'm given a graph of theta equals some angle measure, it's that line, it's the line that goes through that angle measure throughout the whole graph, representing every possible point, every possible distance of r from that theta.